You know that feeling? Your phone? It's just this slab of glass, right? It just sits there, waiting for you to do something. But what if it could be more? What if it could actually be a perceptive companion, something that gets you and your world? Well, that's exactly what we're talking about today. We're diving into a new piece of tech called the V-chip. And this quote really nails it. The goal here isn't just about making phones faster or cramming in more features. No, this is about a huge shift, a fundamental change in how we relate to our devices. We're talking about moving from something that just follows orders to something that feels, well, truly aware.
And that brings up a really cool question, right? I mean, we're used to our phones seeing with their cameras or hearing with their mics. But what if they could use all those invisible signals they're constantly sending and receiving? Wi Fi, cellular, Bluetooth. What if they could use those as a totally new kind of sense? Imagine if every little reflection and distortion in those signals could actually paint a picture of the room you're in.
All right, so let's get into our first section here. The whole idea is to take the phone from being this reactive tool that just sits and waits for you to tell it what to do and turn it into a genuinely perceptive being that understands its surroundings all on its own.
So let's really put this side by side. On the left, that's our world right now. It's app first. Developers code these static screens, screen by screen, and our phones just wait for us to tap our way through them. But on the right, that's the V-chip way. It's AI first. The interface isn't pre-built at all. It's generated by an AI in real time based on everything the phone is sensing. The phone literally thinks, and then it shows you what you need.
So the big question is, how does a phone even do that? How does it reach this new level of perception? Well, it goes way beyond just the camera. It's all about creating a brand new set of senses. Okay, so the secret ingredient here is this tech called digital electromagnetic mapping, or DEM. Basically, it teaches the chip to see the world using signals like Wi-Fi and cellular. Just think about it. It's almost like sonar or radar. It's mapping out the unique electromagnetic weather of any space you're in just by listening to how those signals bounce around. And it's not just using those radio signals. That's the cool part. The V-chip fuses them with literally every other sensor on the phone. We're talking motion from the gyroscope, light from the camera, the Earth's magnetic field from the magnetometer, even the tiny vibrations from the haptic motor. It pulls all of that together into one single unified picture of what's happening. And what do you get when you mash all that sensory data together? You get something they're calling a spectral card. The best way to think of it is like a unique digital fingerprint for real-world objects and even entire rooms. It's built from both light and those invisible electromagnetic signals. This is how the phone goes from just collecting raw data to actually recognizing what it's perceiving. Okay, so the chip can sense the world now. That's huge. But how does it, think about what it's sensing? How does it communicate internally? It turns out it uses this super simple, incredibly efficient internal language that's all based on this idea of resonance, of being in sync with the world around it. And it all happens in this constant three-step loop. It's always running. First, it perceives the world, turning what it senses into these little data packets called reso tokens. Second, it understands what's already on your screen, and it creates screen tokens for that. And finally, it expresses a reaction. It mashes those two things together to generate anim tokens, which create a living, breathing, real-time UI response. And the real beauty of this whole system is just how incredibly efficient it is. I mean, look at how tiny these data packets are. A reso token, the thing that captures the entire environment, is only 32 bytes. That's nothing. This isn't about crunching massive amounts of data in the cloud. It's a super lightweight language that lets the phone have this complex understanding using very little power right there on the device itself. This kind of efficiency, it opens the door to something really profound. We're not just talking about a faster chip here. This is a whole new way of thinking about computation. It's the dawn of a new kind of intelligence that feels way more natural, more intuitive. And it all starts with the hardware, of course. The V-chip is built on an insanely advanced 2-nanometer process. Being that tiny is what makes it possible to have this powerful cognition happening right there in your hand without ever needing to ping a server in the cloud. This is true intelligence at the edge. And just look at these performance numbers. They are,
Well, they're wild. The latency is under 10 milliseconds. That is literally faster than you can perceive. It's updating at 120 hertz, perfectly synced with your screen's refresh rate, and the whole thing uses less than 300 milliwatts of power. So you get this real-time, powerful cognition that's also incredibly efficient. You know, a really great way to think about the V-chip is to see it as the phone's perceptual cortex, or its UI brain. It's not the main CPU that's doing all the heavy lifting for your apps. No, it's this specialized part that's just dedicated to sensing, to feeling, and then directing all the expressive, intuitive reactions of the interface. And that really brings us to the ultimate takeaway, the big idea here. For decades, right, computers have been clock-driven. They operate on this rigid tick-tock metronome beat. The V-chip is proposing a massive shift. A shift to rhythm-driven intelligence. A world where computation isn't just about raw speed, but about syncing up with your personal tempo and the ambient rhythm of the world around you. So what does this all mean for you? What would it actually feel like? Well, imagine a device that actually learns your personal rhythm and timing, your little pauses, your pace. Imagine an interface that's emotionally in sync with you, reacting with subtle animations that just feel right. A UI that's smart enough to adapt whether you're in a quiet library or a loud, busy street. And interactions that are so ridiculously fast, they feel instantaneous. Like there's no separation between you and your tech. And all of this leaves us with one final, really big question to chew on. This whole idea, it points to a future where our devices don't just follow our commands, but they actually connect with us on a much deeper level. So what happens when our technology stops just responding to us and starts truly resonating with us?